We're back. I've been running some minor experimentation here, trying to build a larger neural network. Yeah, it's really complicated, but because the way the convolutional network works is the input and the output have to be the same width and height, but they can have different depths. And then bias, the width and height have to be the same. And then scaling, the width and heights are different, but the depth has to be the same. In fact, I should be calling this scaling to 2D. Let me rename it. Uh, uh, well, I'll rename it at some point. I'm going to rename this at some point. But the point is, even with the small network here, with just 1, 2, 3 convolutional layers, just 3 convolutional layers, it's running really slow. I mean, it's working, but as you can see, it's taking a long time just to show the first frame. And that's a very small network. Any decent network is gonna have at least a dozen convolutional layers. And right now it's running, it's working, but you don't see anything because it's just taking so long to show anything. So this means that we're gonna have to use a GPU. That means Cuda. And still, I'm waiting. I'm just waiting for this thing to show up, but it's really not going to work at all. Let me just pause it and we'll see when there it is. Okay, first thing to notice, it is working, but the images are very wrong. But anyway, it will work eventually. But it is very slow. That means we have to get into CUDA now. I've been trying to avoid this, but because it's just really complicated. But let's start doing CUDA stuff. Okay, first thing. Yeah, first thing. What am I doing? Okay, let's close this. It's gonna take too long. Okay, first thing. I've been trying to get CUDA to work, but it only works in Visual Studio, and I'm not really familiar with Visual Studio. But let's see what we can get. Okay, first a new project. New project. Okay, wait a minute. Okay, that's the new project. Okay, we have to select. What are we selecting? Cuda 16 runtime. Okay, before you can start, we have to install Cuda runtime. You have to go on the Cuda website and then download the runtime and then install it. I'm not gonna show how to do that because the other people who can show it better than me. Okay, build a dynamic library, standalone virtual view. Yeah, Cuda runtime, C++ Windows. Data science, okay. Okay, plus Windows. Okay, install Cuda runtime. Windows, yeah. Cuda library. Cuda library 2. I already made one, but it really doesn't work that well. So let's try to update it. Create a new solution, Visual Studio, Visual Studio, create a new solution. Yes. Okay, everything's the same. Create a Visual Studio project. Okay, now we have some CUDA code. First thing, what is happening here? This is what it's called a CUDA kernel, global void kernel. This is the function that works inside the GPU. Not going to go into it because it's better that you just read the documentation because there's really nothing I can say about that. That's that good. That's a function point. Wherever you see global just means that this is a function that runs inside the GPU. All the coding here runs inside the GPU and will not work at all on your CPU. You cannot access any of the memory. This function cannot access any memory outside of itself. So unless you specify to the memory to be allocated inside the GPU. So this is the most important thing when you're doing any CUDA operation. Right now, thread IDX means whenever you call a kernel function, where is it? Okay, where is it? Where? Oh, add kernel. Okay, this is what you call a kernel function right here. This is the number of blocks and the size and the number of threads inside the block. Again, I'm not going to go into details of how this works, but all you need to know is that whenever you define a function You define a function that runs inside the GPU, and then you call it using this function right here, a triple bracket here. Triple bracket open, triple bracket close, and you add the block count and the threads per count. This is rather complicated, but I'm not gonna get into it. Okay, so it creates a thread for the size right here is what is size? I don't see it. Our size is 5. Size is 5. Add with Cuda. Size, okay. Size is 5. It creates 5 different threads. Each thread gets its own function, and then they run in parallel. And now you get to thread IDX. The block size can be 3-dimensional. Thread IDX.x. Each point inside the 3 dimensions is a thread ID. Is a thread, but each thread has its own coordinates. This is to make sure that that each thread has a different ID. Thread IDX is thread ID.x. You have thread ID.y and thread ID.z. The XYZ tells you where each thread is supposed to operate. This way, the thread knows that it should only operate inside its own block. Each thread operates as inside for a single pixel. Each pixel has its own thread. So all the threads run in parallel. Okay, what else is there? I'm not going to get into anything or any of this here. So the only thing I'm going to do is create my own CUDA library. Okay. Now we're going to copy all these functions right here, create our own functions. Okay. Long CUDA memory. I'm going to call it CUDA memory. If and def CUDA memory. CUDA memory. I tried calling it CUDA device before. Last time I tried this, and CUDA device is already, the name CUDA device is already taken. So I'm just calling it CUDA memory because, well, that fits. Define CUDA memory. And if CUDA memory. Okay. Now I'm going to try to define some basic CUDA functions because I'm going to make a lot of these kernel functions to replace the neural network functions, and having something that works here just makes it simpler. Okay, where am I? Okay, long CUDA memory. What's the first function? Reset device. I do CUDA reset device. What is reset device? Reset must be called before exiting. You don't have to profiling and tools. Okay, reset device. CUDA memory reset device. Okay. Okay, I'm reading off. Okay, where is that thing? Okay, right now I'm reading off the CUDA website and trying to figure out where every device is, every function, what every function does. Okay, right now, yeah, I'm just gonna copy all these functions here. Reset device doesn't take any parameters, so what does it do? Let's just copy and paste. CUDA status. Okay, CUDA status. Okay, CUDA status, CUDA reset device. Oh wait, we have to specify CUDA status. Where is it? CUDA status. Error. CUDA error. CUDA status. Okay. Okay. CUDA error. CUDA status. Just gonna do it as close as I can. If CUDA success, printf. F printf. CUDA device reset failed. There's something else I forgot. Yeah, I got it. CUDA reset failed, and CUDA status. CUDA reset failed, and there's a string to be added. Okay, where is it? Yeah, you have to add a string. Okay, I've done this before. I should know this. Okay, CUDA status failed, and then it returns a CUDA status failed. Whoa, not equal CUDA success. Not equal CUDA success. CUDA status failed. Reset. Return 1. Okay. If it's failed, we return 1, and that's the first function. Okay, what else is there? CUDA set device. Set device is to select, if you have multiple GPUs, you select a specific GPU. Okay, let's just copy everything. Copy and paste. Cuda device reset. Cuda set device. Cuda set device. Oh, just set device. No. Cuda set device. What am I doing? What am I doing here? Cuda set device. Does it work? What am I doing? Cuda set device. Device ID. Cuda set device. Where is it? Unsigned long device ID. Device ID. ID. Is it I? Oh, uppercase I. ID. Device ID. Okay. Now we have an ID, device ID copy. We're just going to go to each of them one by one. If Cuda Status, Cuda set device. That's why I don't call it Cuda device, because the Cuda device is already taken. Get it, excluding Cuda Status. Cuda set device failed. Everything's right. Okay. Next function. Cuda device set malloc. Oh, Cuda allocate memory. Cuda allocate memory. Ooh. This is a complicated one. Okay, Cuda allocate memory. Okay, as you can see, the way it works is that it doesn't return the pointer to the memory. It returns it as a pointer to a pointer. And to be clear, the memory being allocated is inside the GPU, which means you cannot access it directly. If you try to access it, and it's just, well, you're just gonna get a huge error. Okay, let's see. Let me just try and copy this and see if I can get it right. Allocate memory. Cuda, no, Cuda memory. No, Cuda memory set device, reset device, and set device. Allocate memory. Just be clear. Just be sure not to get this. Allocate. Make sure you don't get this wrong. Allocate memory. Void result. I'm reading off the documentation here. Try to get it as close as I can. Result. Oh yeah, we need a light. Unsigned long light. Okay, this is a point. The double star is a pointer to a pointer. You should already know this. Is a pointer to a pointer. So we take a pointer and you pass it a pointer, and you pass it a pointer to the pointer, and it returns Cuda malloc. Okay. It sets the pointer to the memory that has been allocated. Cuda malloc. Result void. We have to cast everything to what it expects. Void pointer. No, pointer twice, not 3 times. Result. Length. Okay. So far so good. Cuda memory, allocate memory failed. Gets out a string. Okay. So far so good. Next function. Cuda memory malloc, Cuda memory malloc, Cuda mem copy. Oh, that one's complicated. I remember trying that one and it really messed me up. Cuda memory host to device, device to host. So basically there are 3 types of, at least 3, maybe there's more, I don't know. Okay, so it's one function that copies memory for between different parts of the GPU, and from the GPU to the main memory, and then from the main memory back to the GPU. So having 3 functions that all do the same thing is kind of complicated. Okay, you have to specify memcopy host to device, memcopy device to host, and memcopy host to host. So I'm getting this from the documentation. I need to copy each one selectively. Well, individually, I mean. Okay. Cuda memory. Copy memory. Oh no, I'm not gonna use one function to the 3 things. I'm gonna have the 3 functions. Set memory. No, set memory doesn't tell me anything. Set device memory. Device memory. Okay, the name device into the GPU. The host is the actual computer, the main memory. The device is the GPU itself. So when you see host and device, this is what it means. Memory. Okay, before I continue, one thing I keep forgetting. When we build a Cuda program, there's one thing that really messed me up. Like for days, I spent days trying to figure this out. You have to go into properties in the GPU thing, and then Cuda C++, and then here is you see common device host command line. Cuda C in the properties C++ common host device. You have to select device and then code generation. Here it says compute 52 SM52. This is one of those things that really can mess you up a lot. Okay, 52A, and this is how you fix that. Yeah, it took me days to figure this out. You have to go into in Wikipedia right here. Go in Wikipedia and then type Cuda in the page Cuda. You have to do that for each computer. You have to select your own computer because each computer is going to be each GPU is going to be different. And then down here you have to find supported GPUs, and then you have to look through all the lists right here and then find your own GPU. Mine is a 750 Ti. Okay, so depending on which GPU you select, you have to change the right here. You have to change code generation from compute 52 to compute 5.0. Mine is a 750 Ti. So whoa, what am I doing? What is this? There it is. Mine is a 750 Ti, so I have to select 5.0. Yeah, this is one of those things that really takes a long time to figure out with the Maxwell GPU. So depending on what your GPU is, you have to select this specific one. Mine is a 5.0, so I have to change this from 52 over to 50. If you don't do that, it just simply will not work at all. Which is something I really don't understand why they don't just select that automatically. But there has to be a way to do it, to change it manually, or actually you can't. Oh, I just don't understand this at all. Okay, maybe there's something you can do to change it, but I have no idea what it is. But here you have to do it manually, and you have to do it for every time you compile the program. There has to be a better way to do this, but I don't know what it is. Okay, so change it to 50 and okay. Okay, so that's something. Okay, set device memory. Okay, device memory. How do we set device memory? Okay, void device memory. Set device memory. Device memory. No, not void double pointer, just void pointer, device memory. And a void again. Void point buffer. But host memory. Host memory and length. Device memory, host memory, and length. Okay, Cuda set device memory. Cuda mem copy. I got lost here. I got lost talking about this other thing. Okay. Oh, darn. We have to copy this whole thing because you cannot get this wrong here. Okay, device memory. Void device memory. Now we don't need to specify void. Device memory. Device memory. Host memory. And length. Obviously the length have to be the same for both. Oh, there's more. Oh, forget this part. Copy memory host to device. Set device memory host. You have to copy from host to device. You have to specify this right here, otherwise it won't work. Oh, get rid of this. No, Cuda. Okay, mem copy. Yeah, I got this wrong. Okay, Cuda mem copy. Copy memory host to device. Okay, host to device. Now we copy this. We'll have to set it get device memory. Okay, set device memory, get device memory, and device to host. device to host. Hopefully it works. Okay, device to host. Now get device memory, copies, does exactly the same thing. Everything, all the parameters are in the same order. Whoa, no it's not. Whoa, okay, we have a problem. Okay, the parameters are not in the same order. Wow, I got this wrong. Okay, we have to change it back here. This is the destination. Ooh, this is really weird. Okay, you have to get this right. It's the same function, so oh, we forgot to copy this right here. Host device memory, allocate memory, set device memory, get device memory, length, getter, string, everything the same. Yeah, I don't like this the way it's set up here. That's just a matter of style. I like to be able to see the bracket. This is just a matter of style, but personal. That's just a matter of personal choice. Okay, set device memory, get device memory, and that's it. Okay. Now the next function, the final one, copy device memory. Okay, you're gonna need that one. Copy device memory. Source memory. Is it source memory? Destination memory. Device destination. Destination memory. Now device destination, not destination. DEO. Oh, DEON. Device destination. Device source. No. Okay, so we copy from destination to the source. I'm not gonna get into the other thing. Okay, device destination, device source, length. Okay, Cuda. Okay, copy device memory, device destination, device source, length, and this is the part I don't understand yet. Just copy this, and then now you have to figure out is it host to host or device to host or host to device. Okay. Device to device. It has to be device to device. Let me check. Okay, it's device to device. Okay, this one copies from the host into the from the device into the host to from GPU memory to CPU memory, and this one does the reverse, and this one just copies from GPU from one segment of GPU memory to another segment of GPU memory. Okay, so far so good. Next function. Okay, what else? What else is there? Get last error? No, that's get last error. Cuda Status get last error. Do I need this? I don't need this. Device synchronize. Oh, that's an important one. Okay, this is important. Let me just copy the function right here, just so I don't have to do anything else. Okay, copy function, and now copy this. This is extremely important. Device synchronize. Whenever you call a kernel function, you're calling multiple threads, but the average GPU, my GPU only has like 500 or 600 cores, 500 cores, and sometimes you can have like 10,000 threads. So obviously you can't run 10,000 threads on just 1,000 cores. So they have to take turns using the 1,000 cores. So it might not finish all at once. So and while it's finishing, the computer will still continue to do stuff, and you cannot call CUDA functions while the CUDA calls are busy. So the point of synchronize is to tell the computer to just wait. Just wait until everything finishes. CUDA memory device synchronize. CUDA memory device synchronize. Okay, get device memory, CUDA memory device synchronize. Is it device synchronized? Synchronized device. Yeah, it's called synchronized device. I don't know. Okay, CUDA memory synchronized device, and what? It doesn't take any parameters. Okay. Okay, so you need to call this after every kernel call. Every time you launch a kernel, you have to call device synchronize. Okay, what else is there? Oh, you have to free the memory, of course. Cuda free. Okay, let us copy this. Cuda free. You allocate the memory and you free the memory. Okay, Cuda memory, free memory. Free memory value, memory, or result, source, or just source. Just call it whatever. And then Cuda free. We'll just call it whatever. And source. Cuda free fail. Cuda memory free memory failed. I don't know why it would fail, but it might. Cuda success, Cuda free. And that's it for Cuda memory, I think. Unless I missed something. That's pretty much all of them. Okay. Okay, this is the basic memory functions. That should be enough, right? Okay. Now let's try basic Cuda. I don't know what we could possibly do with Cuda. Oh, and one more thing, we have to create a DLL because I can't quite figure out how to get Cuda to display Windows Windows stuff. If and def win main, no, it doesn't work. Add with Cuda. Let us get rid of all this. Yeah. Okay. Get rid of all this. And then we're gonna use we're gonna create a null array. Okay. Okay, type null array. I don't like this. Okay. Cuda. No. Type def structure. Okay, where am I? Projects. I'm just gonna copy type null array. Well, oh wait, it's not possible. Is it? No, it's not. Okay, let's just copy it. Okay, we don't need array shape, array length, type null unit, everything's the same, and we'll just copy this right here. Okay, let us type null array create. Okay, type null array create, and like before, we just use length. Okay, Cuda null unit, data length, no, type shape assign, no, get length, we don't need that, length, data length, oh, not malloc. Okay, now we're gonna start using this function right here. We set device allocate memory, set device memory, allocate Cuda memory allocate memory. Okay, if Cuda memory allocate memory data or void not void pointer data and data length. Data and data length. Okay, why is that here? And get rid of this. Okay, if Cuda memory allocate memory data, we are good. Array length equal length. Array size equal data length. Size of Cuda node length. Everything is good. Okay, we have allocate create a Cuda null array. Create Cuda null array as opposed to the other kind of type null array. This could come back to bite me, but I don't care. Cuda null array destroy. We're just gonna copy everything. Get rid of all this. I'm just gonna turn it into a DLL because otherwise it's just gonna be too complicated. Okay, Cuda Neural Array destroy. Cuda Neural Array destroy. No, Cuda Neural Array. Okay, we just copy it. Now Cuda Neural Array. Cuda Neural Array. And set everything up. Cuda free. Cuda free memory. Cuda memory, free memory. Parent.array data. Void. Don't know if that's necessary, but we'll just do it. Okay, so far it's the same thing. Now we have to copy memory in and out and across the device memory. Okay, Cuda Neural Array set memory. Cuda Neural Array set data. Okay, this is to copy data into the neural array. You cannot access the neural array directly, so you have to use this function to copy memory into it. Okay, is it Cuda Neural Unit? It's not type neural unit, it's Cuda Neural Unit. Oh, Cuda Neural Unit. Where is it? Type neural unit. Cuda Neural Unit. Cuda Neural Unit. This may turn out to be very complicated later, but Cuda Neural Unit. Buffer. Unsigned long. Not on. Signed long. Buffer size. Okay. Okay, Cuda Neural Unit. So how do you copy memory into it? Okay. Okay, Cuda Neural Array. What am I doing? Same thing. If parent equals 0 or buffer equals 0, return 0. Okay, I'm getting this. If buffer equals 0, return 0. Okay, Cuda Neural Array set data. Oh no, if length not equals parent, not parent dot array length, return 0. Not length, buffer size. What do I call it length? Buffer size. Okay. Okay, Cuda Neural Array copy. Set device memory. Okay, set device memory. Is it set device memory? Yeah, it's set device memory. Okay, return. Okay, return. Okay, the memory set device memory. Okay, device memory. Parent.array data. No. What am I doing? Oh, come on. Oh, it's still messing me up. Parent dot. Come on. Why is it doing that? Parent.array data. Buffer size. Yeah, that's it. Oh, wait. Oh, void. Is it void? What is it? Oh. Cuda memory set memory. It's not going to work. Cuda memory set device memory length. Oh, it's not buffer size. Oh, wait. Wait, I made a mistake. Okay. It's buffer size times size of. Okay, let me just copy from here. Size of type neural unit. Oh, that would have been a mistake. Okay, why doesn't like it? Cuda neural incompatible type void? What? Oh, Cuda neural, but oh, okay. Buffer. That was a mistake. Buffer. Okay. It's buffer size times size of Cuda null unit, because buffer size, it only equals the size, the number of units. Set data, it transmits the number of units, not the number of bytes. Okay, it's a null array, not an array of bytes. Okay, so everything is set. Okay, get device memory. No, get data. Oh, otherwise this could have been terrible. Okay, is it buffer or result.array data? Parent.array data. Get data. Parent.array data. Wait a minute, I'm gonna check something. Oh, now I remember. They have to be the same. The parameters are in the same place, even though they're reverse here. Okay. Get device memory is no. Stop it. Get device memory. Parent.array data, buffer size, everything the same. Everything's exactly the same. We just change the name of the functions. Okay. Now the next one. No, we don't need a copy. Not yet. Not yet. And so far, I think that's it. We copy it and we copy it in and then copy it out. We don't need anything else here. All right. Now we have to set this as a DLL. Okay. How do you make a DLL? Okay. New file, header file, Cuda library. I'm gonna have to figure out how to do this. Okay. Now I got the code for creating DLLs. Let me just copy and paste this. Yeah, that's interesting. Okay, let me make this work. Cuda library, if and def Cuda library. Okay, if and def, if and def Cuda live, no library. No, it's library. What am I? I can't spell. Cuda library dot h. Okay, define Cuda library and if. Okay, and if. Okay, what am I doing? And if Cuda library. What is that? Okay, let me just copy. Ooh, we need to specify because it's going to compile in different ways from here, between here and here. Cuda library export, Cuda library export. If def Cuda library export, Cuda library, no. Let me just call it something else here. Cuda library kernel. Because it's called kernel. Kernel.c. Oh, there's one thing I forgot to specify. Cuda files are called kernel.cu. Not kernel.cu, just .cu as in Cuda C. That's one thing you have to remember. That's just something it does. Okay, if and def, you have to define the DLL here because otherwise it's just going to compile. Because here you do one thing, you have to export, and then whenever you use it, you have to import. Okay. Okay. I need to get this right. Define. Not define. Define Cuda library kernel. Here you have to define it library kernel because whenever it's inside this file, it has to import, and whenever it's outside that file, it has to export. Include Cuda library.h. All right. Oh shoot. Include Cuda library.h. Ah, whatever. Anyway. Okay. Cuda library. Let me make sure I got it right. If and def DLL export. Define DLL export. No. Okay, they will export. Okay, let me do it my way. Okay, now we need to define all these functions right here. Cuda memory set device. Okay, let's just copy all this function here, 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 and here. These are all the basic CUDA functions. Free memory. Okay. Oh, and one more thing. Don't forget this. Extern C. Because otherwise, different programs might not use this properly. If in def, oh, wait a minute. Let me just copy from another source here. Okay, save CUDA library. CUDA library.h. Okay. Oh wait, did I save in the right place? Let's save somewhere else. Copy. Okay. DLL export or DLL import? No, DLL export. Okay. It's going to have different meanings depending on where you are. Copy. And paste. And whatever. Duh. Okay, let's get rid of this. Dab, 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 dab. I'm not gonna finish this tonight. It's just taking too long. And if and if, and let's copy this right here. This has to be outside because it needs to be exported. Good. This is everything that I've been doing. Include CUDA library. Oh, it's in the wrong place. I don't have no idea what I'm doing. Include CUDA library and then copy and paste. CUDA null array, say allocate. CUDA library set data. CUDA library get data. And CUDA library destroy. CUDA null array destroy, not CUDA library destroy. Alright. So far, this is about it for creating a CUDA library. We have to compile, but there's really no point doing that now. It's just gonna take too long. It's time to go to bed. Okay, so this is pretty much all the code for making a CUDA library. Next time I'm going to test this and make sure it works. Right now the include file is not the right place, but everything is right. I'm just going to upload the code and finish that in a part 2 later.